Hi, everybody. Can you hear me? My name is Ziba Cranmer. I'm from BU Spark. We are one of the entities that's been incubated under the Hariri Institute. I'm really hoping I don't have any typos because this is a really big slide. Okay, so I'm going to talk about student engagement, and most of the time is going to be spent hearing student projects, projects that students have worked on in connection or in the orbit of Spark. So I'm going to give you a brief introduction to Spark because it also could be a resource for those of you in the audience. So we are a technology incubator and experiential learning lab for computer science and engineering projects. And I say projects because we're not necessarily just computer science and engineering students. Many of the projects we do are interdisciplinary. We really have three goals. One is to support student innovation. The other is to provide opportunities to apply technology skills in real-world settings and gain skills around that. And then the third is to foster an inclusive and innovative community at BU. So the first program that we're going to hear from Jorge and Telltale in a second is the student innovation side. We have a semester-long program where students come in with ideas. We provide them mentors from industry, as well as a structured experience over the course of a semester and a demo day at the end of semester for them to pursue their projects in a supportive context. And so you're going to hear from a student innovation team, Telltale, over there. This is just sort of the impact that we've had in the 3 years since we were founded in January 2017. The second is the X Lab, what we call the Experience Lab. And this is where we recruit projects from outside the university, from across every sector, from nonprofits to governments to startups to companies to faculty. And students work on those as part of class projects or as paid internships. And right now we're collaborating with 5 classes. We're trying to figure out how to scale this. That was one of the conversations we had at our table. How do we partner beyond BU, and how do we do that in a scalable way so that we can work with a lot more of the faculty maybe that are in this room? In the second, in this zone, you're going to hear from Michael Jabala, who's going to talk about a project that he has been working on with the city of Boston. The third is student clubs. So there's about 28 technology-focused clubs. They seem to be growing and evolving constantly, which is great because the technologies are evolving constantly, and student clubs form around those. And they're doing their own work. So the third speaker is Julius, and he's from the Machine Intelligence Club, and he's going to speak about a project that he's done in the course of that work. So just to give a couple of highlights, we do a lot of work with cities. This is just kind of a smattering of the towns and municipalities that we've done. This is perfect for data science because a lot of the problems are the same across all of these jurisdictions, and most of them are resource-constrained entities and really can benefit from help. So we have repeatable problems, similar data sets, and a long tail of potential partners. But I'm going to talk, my font's a little off. I'm going to talk just about 2 highlights of the types of programs that or projects that we're really excited about. So we want to do projects to give students an opportunity to learn. We also want to have impact. And I think that there's a way to do that. And we have 2 projects that I'm going to highlight. This first one, you may have heard, I think it was 2 or 3 weeks ago on NPR, they were talking about a project, a multi-article series that was looking at the color of money, or the impact of state procurement dollars on and spending with minority entrepreneurs. Well, that was a project that Spark students worked on. GBH reported on it, and we were cited for the data science work we did. We scraped a public website, 10 years of data, minority-owned databases, bids, procurements, contracts, and constructed it in a way that investigative journalism team at WGBH could work on that subsequently, which they did for over a year. We had multiple student teams over multiple classes work on this data set, and it was reported and they were cited in the byline. So that was a huge success, and I think a sign of how we can, if we can structure it right, have a real world impact. This is another one we're doing for the NAACP Boston, which is hosting the national convention this year. And as part of the lead up to the convention, which is a big deal, they're looking at the issue of Black communities and Black people in different sectors in society. we are working on a media project looking at the last 5 years of the coverage of Black communities in Boston media. And WGBH is also helping us. They're kind of the mentors in this project. And then the last one, this is sort of another zone. We have a state representative who has asked us to do an analysis on the value of surplus state-owned land to be used for affordable housing or to sell in order to get money for affordable housing. This is a kind of bill that, if it doesn't have data behind it, gets stalled, gets sent to committee, and maybe never, it doesn't get moved forward. Just found out today that the project that the students did last semester, where they did an analysis of all the state-owned surplus land, working with a lot of public data sets, and were able to create an estimate of that land, to make a compelling case that there's something here, that it should be advanced. And they figured out that there was 2,651 parcels, 1,850 acres worth, I think it was in the end about $1.2 billion worth of land. And it just got reported out of committee as a result of the quick work that these students were able to do to make the case for more data. And this is what we see a lot. The types of projects Spark is good at, unlike SAIL, which is kind of more production level work at Hariri, is those exploratory projects to make the case for further research, for deeper level analysis, and more involvement by other government agencies, other faculty, research, et cetera. Okay, so we're getting some emerging expertise areas as we repeat project areas as partners come back. We're doing a lot around sustainability, a lot around public health, a lot around cities, especially housing, land development, real estate, and public works. A lot around equity, gender, race, economic issues, and then a lot around criminal justice. So if that's an area that any of you guys are working in, we'd love to partner with you and explore what else we can do. All right, so that's Spark, and now I'm going to turn it over to Tall Tale. You guys want to come up here? Oops. Yeah. Okay.
Hello. Oh, okay. My name is Jorge Nario. I'm currently a senior at Boston University, and I'm going to be graduating this spring, and I was a fellow.
I'm Noah Naiman. I'm also a senior here at Boston University studying computer science. I'm also graduating this spring.
Yep. So the basics of our project was, in second grade, I was diagnosed with a learning disability, dyslexia, as well as a few other that kind of inhibit the learning and processing of languages. So I was unable to read a book until about 5th grade when I went to a specialized school. And between 2nd and 5th grade, there was a lot of times where like my peers would be talking about books like Harry Potter and things like that, and I was never able to catch up. And especially 10 years or so, audiobooks were less available. So our goal was to try to see if we can create a better way of generating audiobooks and then also making it just more accessible.
So me and George have been friends for years, and a few years ago we were discussing books. I read books pretty much constantly. When he told me this, we started talking about solutions. We realized audiobooks was a great solution. However, the cost of an audiobook can be upwards of quadruple that of a paperback. As well, most of them aren't exactly available in multiple formats, narration issues, that sort of things. And the production of them can be incredibly expensive. Luckily, there was Spark.
So we kind of decided, after I took a machine learning class and did some machine learning for my work, we decided let's try to apply deep learning, because that seems to solve a lot of things. If you just make big fancy nets, it kind of does some things. So we used a model that we originally took from Google, and it's called Tacotron. So the way this model works is we take some hours of someone's voice and we have it transcribed. That's the difficult part. Then after that, we're able to train an AI to start to replicate their voice. And then from there, we can then have it generate new text. And the important takeaway from this is that it's very different than a lot of the most text-to-speech you'll see right now. So for example, Siri, which a lot of people are familiar with, or Alexa, is concatenative. So the way that works is they had a speaker say a bunch of syllables, they chop them up, and then when they read books or read text, it kind of just adds them together. So the resulting voice is a lot more robotic. Well, this learns the way the speakers talk. It learns the way they they pause in their sentences, it learns the way they say certain words, and then we're able to infer. So after we do the original training, which we needed Spark's help for because it takes a lot of money, each voice would needs to train over 25 hours on multi-GPUs. Each voice would be, we tallied up several $100s. But after you have a voice, the actual production of an audiobook is very cheap. We actually can do it faster than real time. We can about the fourth of the speed. So if you have a 20-hour audiobook, we can generate that in 5 hours.
So, over the course of one semester, oh, thank you, we were able to get 3 voices, and we'd like you to hear them.
Hello world. My name is Tall Tale. Did you know that when you buy an audiobook, you are paying upwards of triple the cost for a paperback? And the book you are looking for may not even be available in an audiobook version. Plus you only get the book read in one voice, no matter how many characters there are. I have been created to solve this problem.
Using cutting-edge deep learning technology, I can clone voices. This allows for me to create custom audiobooks at a low cost. I can also create audiobooks with multiple speakers.
I am more than just an audiobook generator. I am here to help spread information, to make listening to stories more fun,
More dynamic.
and more affordable than ever. I am Tall Tale, and I am here to give you the full story.
Thank you.
Hi, I'm Michael Jabala. I'm a senior. I'm currently studying computer science and statistics. I'm also a part of the Tall Tale team. But this is for the Spark X Lab. This is the Boston Planning and Development Agency's Main Streets project. So a quick overview of the project. The Main Streets Initiative, it's a project by the BPDA, like I said. It aims to aid commercial districts of Boston, analyze, or accurately track and analyze how these districts evolve, and allow Main Street directors to focus on servicing businesses and not data collection, which is where I come in. To do these things properly, they need a lot of data, and they need specifically business data. So the current method of data acquisition, they use a mix of surveys that they send out, that they hand collect, and expensive databases which prove to have poor coverage and maybe missing a lot of the businesses that they really need. So our proposed method for data collection, at least initially, was to query Yelp and Google for specifically hand-picked radiuses of 150 meters, filter the data according to the specific Main Street shapefiles, and then remove the duplicates, find what businesses were common between Yelp and Google, and then check discrepancies with a human verified set from Google searches and the Main Streets directors list, and sometimes the expensive databases we talked about. And also a merge algorithm was developed because it's not easy to merge such different data types such as Yelp and Google. So issues with this initial method was there were significant discrepancies. We didn't get a lot of what we were supposed to, especially when checking with the database, which we were already suspicious of, and even manual Google searches, which really alerted us. A new iteration was then created to further reduce these discrepancies against the manual Google searches, so we focused only on Google for this one. The city of Boston has a very convenient set of all addresses for the entire city of Boston. So we took every single address in the city of Boston, cut it to the shapefiles, and then queried each address for 50 meters. So this is large amounts of overlap, but it's overlap in high address areas. And then, again, like before, merge and match. So this algorithm significantly brought down the discrepancy amount. It was more expensive because of the overlap. It overlapped in a lot of duplicate businesses were found in the Google queries. So that may be a downside, but after speaking with Google, they revealed to us that on queries, they don't return every business for a given area. So the overlap is actually much welcomed because it allows us to get businesses not previously requested. The work forward is to look even further at the manual results because we still didn't get all of them. Google may not still be returning all of them to us. or they may be invalid. So we want to create an approach to use the Google Search API to check our discrepancies, to check things like the manually collected and the expensive database data to see if those are legitimate discrepancies that we should be worried about. And that's where we currently are.
All right. Hi, I'm Julius. So I am a current junior doing the combined bachelor's and master's program, graduating next year, and in CS. And so I run the BU Machine Intelligence community. So reason why it's actually a BU subcommittee of this thing called MIC Inc., which is basically a cross-college community for like other colleges. For example, is like Harvard and MIT, and essentially we do all things related to machine intelligence. So that would be AI, machine learning, deep learning, all those subfields. And so we really cover a broad set of topics. Our club this semester recently split into 3 subcommittees: our research committee, our workshop committee, and our society committee. And our research committee focuses on doing projects and having paper discussions for more advanced students. Our workshop committee focuses on teaching. We have a course called CS 200 in the fall, and also we do just workshops, weekly workshops for this semester as well. And our society community talks about social issues with AI and how AI impacts society. All right, so the images might not be loading for some reason. These images were essentially some students we had interacting in our course. So our first course that was ever done, like it was the first course, 1 credit course that was run by students completely, and it's on the topic of machine learning. And the goal was to introduce just curious students, people that didn't have too much background in math or CS, and just introduce them to ML and try to accelerate them through initial first half of the semester of workshops and tutorials, and then the later half of the semester they would do their own project. And so our e-board would help guide them throughout the whole way. I was the course assistant of that. And so we had all the students developed our own slides, our own code, and we covered a lot of different topics in machine learning, and specifically deep learning, because most of the state of the art is in there. Okay, so some of our student projects involve these. We had 15 in total. And so like American Sign Language classification, where you would have an image of someone holding up their hands in a specific shape, and you would try to classify that gesture as a certain character or a certain word. And then we have heartbeat classification. In this project, there was about 3 different classes of heartbeats, and the input would be audio data of the heartbeat. And then malaria detection within image cells. This one was, your input is image of, I think, a biopsy of, or actually not biopsy, but a microscopic image of some cells, and the goal was to detect malaria. And also reinforcement learning, playing Hex, it's just a game. Reinforcement learning is a type of learning, machine learning, where you have an agent in an environment that's constantly interacting. So it'd be more of a like a real world setting. Instead of a static classifier, it's something that actually interacts and has a feedback loop. And then we have our last one, cuisine classification. Basically, given an image of some type of food, classify what kind of cuisine it is. So that's just some of our projects. We still had a lot more, but these were the more successful ones. They got near 90% accuracy on most of them. And so, damn it. All right, so this last fall in September, we had a machine intelligence conference. This was more just a general conference for university students and people around Boston in AI to come basically present their work, and especially students, researchers. And it was organized by the Machine Intelligence Community, Inc. So not by us, but also part of us. And finally, here's some of the work that I did last semester. So basically, I work in reinforcement learning and explainable AI because I'm under supervision of Professor Kate Seinko. And so basically, I had these two subfields, and I wanted to see how I could join them because I'm more oriented towards reinforcement learning, and Kate's primarily based in explainable AI. So basically, the goal is to try to explain, like, for example, in a self-driving car, why did it pick certain actions over other actions? For example, if it was at an intersection, why did it go straight instead of turn left? And so as you can see on that picture right over there, its explanation would be it didn't want to turn left because there was an oncoming car. So my solution was to produce a predicted video of what would happen in different scenarios based on different actions. And so I basically built like a deep learning model to predict image frames from some time point. So yeah, so overall, the main challenges of our organization really is just compute power. So our community is mostly running on just like the SEC that was given to us through our course. But also sometimes we need like very specialized things, hardware requests. For example, in reinforcement learning, it's not so much that the GPU is the bottleneck, it's more the CPU. And so having lots of cores would be more beneficial for that. So we're open to any collaboration in the future. You can reach us at mic.bu.edu. So we have our website. Also there you'll have information to our email list or our email if you want to send anything. So yeah, that's all.
I'm going to introduce the last speaker, is Darvish Terraport. Darvish is the technical lead at BU Spark, and he's also a success story of BU Spark, although we really can't claim any credit. So he was a fellow, our first class of fellows 3 years ago, and worked on the X Lab, and we convinced him to come work with us, and he's been leading a number of really pretty amazing projects with students through the X Lab and through the practicum, which he also leads. So, as well as running his own startup, ACAS, which came out of the, which is Aircraft Collision Avoidance System, and he can tell you all about that sometime too. And I will turn it over to Darvish.
Afternoon. Thank you for having me. I'm Darvish, and I'm the technical lead at BU Spark. And this talk is going to be a little different than all the others in that I'm going to talk about the conspicuous absence of a group that I think we all ought to be welcoming here. They're absent at worst and underrepresented at best, and I'm talking specifically about the hackers, the builders, the makers. These are people who have relentless optimism, and they have a particular propensity for permutation-driven development. So by show of hands, how many folks here have used a Linux operating system, either over the course of their research or directly? Yeah. Most of you here, if you have an Android smartphone, you definitely use Linux. If you connect to the computing cluster to train any deep learning models, you almost certainly also have used Linux. Well, Linux started out as a weekend project by Linus Torvalds, who is the quintessential hacker, this person that I'm describing, who has this urge to continually experiment, to continually try to make things better. And in the software world, these hackers have been responsible for, starting billion-dollar companies or coming up with a transformative open source movement that shapes the landscape of software engineering to this day. And yet, ironically enough, they've been rather siloed or distanced from the data science field. It's especially intriguing to me when you think about the fact that as data science becomes a modality for cross-disciplinary collaboration, that that translucent wall of divide between software engineers or between the hackers and the data scientists becomes more and more palpable. So with the remaining time that I've got, I'd love to explore why that happens. I'd love to propose a few solutions. And at the end, I have an ask of all of the researchers here. So spring of 2019, there's a class that I teach on software engineering. We partnered with the city of Boston. Specifically, this was the Mayor's Office of New Urban Mechanics. They wanted for us to build them a machine learning model that would be capable of distinguishing between damaged sidewalks and undamaged sidewalks. Now, the pipeline for that looks fairly simple. So we started out by gathering a bunch of images from Google Street View, and then we attempted from those images of streets to segment the sidewalks and isolate the sidewalks. And then after that, we wanted to classify those sidewalks as damaged or undamaged. Predictably, the worst part of this, or the most mundane part of this, was obviously the gathering of the data. And I think I can look at war veterans right here when it comes to data gathering and pre-processing. Yes, it's a pain. But interestingly enough, the tediousness notwithstanding, the hardest part of this project, what really almost threw a spanner in the works, was the segmentation. So we were looking at this model called Deep Lab. Anyone ever hear of Deep Lab? It's a semantic segmentation model, a deep learning model, which basically attempts to segment individual elements of the environment that it's looking at. So if you look at, let's see, this image right here. So there's a picture of a street and a car, and if you put it through the Deep Lab neural network, well, it segments it into the sidewalk right here. There's a car, and then other parts of the sidewalk here. Fascinating paper, and they touted state-of-the-art results, and we were very impressed. So we looked them up, found a rather trivial implementation of Deep Lab, and we attempted to use it for our benefit. And this is what we came up with. That's apparently Deep Lab's conception of a sidewalk. Well, we thought we were going to have to call this project off because, well, I mean, you really can't do much with that. I don't know if that's damaged or if the neural network just wasn't capable of segmenting it. And then you look at the results over here, and you just look at how marvelous they are. Well, this is one of the biggest bottlenecks for builders, for hackers, for people who'd love to experiment with deep learning. This is one of the biggest bottlenecks for them to get into machine learning, which is reproducibility. And I'll constrain it even further and say replicability. When someone publishes a paper and they give us amazing results and they say, this is what we've come up with, it is helpful from an engineer's perspective to be able to replicate those results. Not because there is any doubt about the validity of your results, but because understanding is the first step to being able to improve something. And for me to be able to use, the seminal research that you've come out with, I need to be able to recreate it before I can start tinkering with it, before I can start breaking into it, before I can start making improvements or making it worse, as the case might be. But in either case, I'm coming to you from the perspective of a machine learning user and not a machine learning researcher. So anyway, it turned out, thankfully, that Matt Smith, a data scientist at the city of Boston, said, you don't have to worry about segmentation just yet. We actually do have a collection of annotated sidewalk images that you might be able to use to work on the third step of the pipeline, which is classifying images as damaged or not damaged. And here, there's an example of a rather beautiful neural network called ResNet. How many people have heard of ResNet? It's a fairly amazing neural network. It was remarkably accurate at classifying sidewalks as damaged or not damaged. And we were able to use those pre-existing images that Matt Smith had given us to be able to say, okay, we've actually got a model that works. Now, here's the thing. When you bring something like this that you can give to an engineer or to a hacker or to a builder, and please understand that I'm not using hacker with the negative connotation that it's got associated with it. When I say hacker, I very much mean a tinkerer of systems, someone who likes exploring things. When you bring something like that to one of these guys, well, there's a lot of buy-in. They start attempting to make it better. Downstream, the impact of a well-done research project leads to remarkable, remarkable results. So what do I mean by that? Well, having shown that you could actually classify sidewalks as long as you're able to segment them, as long as you're able to isolate them the way they claim to have been able to do here, we were able to then pitch this to Stantec, who is, are they a corporate partner of Boston City?
Yeah, they're like a consultant.
So Stantec, a company that works closely with the city of Boston, bought into this idea, and now they've committed some amount of money for us to be able to build a wheelchair, a semi-autonomous wheelchair that drives around the city of Boston collecting data on these sidewalks so that we might then eventually tackle the second problem of segmentation. So my ask of people today, for researchers in particular, is if you are going to conduct amazing research and then you're going to publish papers about it, please also consider making the code available for us to then be able to tinker with. I don't mean to, it's not all doom and gloom. The NeurIPS, the Neural Imaging and Processing Systems Conference, actually just came out with a new mandate that requires that any researcher who submits experimental results should also publish that code. One of the myriad benefits of this is that you'll be able to take that information and downstream come up with some pretty remarkable things. So that's largely what I have for you. Yeah, thank you.
I think, is that it? Or I guess we have, if there's any questions for anybody in the group.
Oh, can I say one last thing?
Yes.
Sorry, this slipped my mind. This is very important, very, very important. If you do disseminate your code with the intent of having other people use it, please, please include a license in there. I can't tell you the number of times I've gone on the internet and found these beautiful GitHub repositories of people, having actually shown their research, and you run it and everything works as expected, except you can't do anything with it because it's not licensed, so legally speaking, I can't touch that code. So please definitely consider licensing it. Thanks. Ideally open sourcing it under a permissive license. Thanks.
All right, any questions? Any comments? Oh, thanks. Thanks, Wesley. All right, so I guess we're gonna turn it over to coffee. Is that what's next? Thank you very much to all of you guys for coming to present.